Okay, I don't know how good the sound quality will be here. I've turned on a fan, I'm testing it, it's very loud. Anyway, um, so now that we've talked about different types of parallelograms, we want to figure out what's the best name for one. So basically, the lower you are on that flowchart before, the better you are for name. Okay, so this one, C has to be square. It has to be 90 because these are opposite. Since these are the same and these are the same, and these are 90, each of these is 90, and these have to be the same. But because these are equal, these are congruent, that means it's isosceles, so that means this is also E, and this is also D. So in fact, since E and D are the same, because they're opposite interior angles, and they make up that 90, they're actually each 45. And this thing, therefore, has 90 degree, 90 degree, 90 degree, 90 degree. This is a square because all of the angles are 90 degrees and all of the sides are the same. So this is actually like the most, specific. Okay, this one, this is 110. So this is 70, and this is 70. Since this is 110, and this is isosceles because this is right, that means this is right. And if these two are right, it actually forces the other two to be right. So K is 45, H is 110, G is 70, F is 45, and this thing is a rectangle. If it had been a square, these would all be equal. They'd all be 90, but because of the 110 and the 70, that means that they are different lengths, and this is a rectangle, which is pretty specific. This one has sides that are all the same, so it's at least a rhombus. This is 25. This is 7. So this is 7. So this is 7. C, because these are all the same, well, no, 39, B, this is isosceles if you take this entire triangle here. So if this is 39, then this is 39. And this is a parallelogram, so this is 39. And this is 39 because they're alternate interior angles. So 39 plus 39 is 78, which means A plus B is what remains of the 180, which is 102. That's 180 minus the 78. And A and B are the same because it's a rhombus. So A and B are 51. And then that means this value here, which is equal to C, we've got 39 and 51 making altogether 90. So this one is 90 and this one is 90. And in fact, as I mentioned before, if it's a rhombus, then they are always 90. So this one, having all the traits of a square except that we've got 78 degrees in these corners, rhombus rule is the best we can do. Okay, so ABCD is a rectangle. Oops, I need a pen. Pardon that doesn't look like a rectangle. AB is 2x plus 14. CD is 4x minus 12. AD is 9. And we want to find AB and AC. So first, let's find AB. So we have 2x plus 14 equals 4x minus 12 because it's a parallelogram. Subtracting 2x, 14 is 2x minus 12. Adding 12, 26 is 2x. X is 13. So that means that AB is 2 times 13 plus 14 is 26 plus 14 is 40. Now, this is also 9, but that's not what we're asked. So we have so far AB is 40, and we want AC. So let's just consider the facts about the upper triangle here. We've got 40 and 9, and we're looking for this one. So square root of 40 squared plus 9 squared, square root of 1681 . $41. It's probably one of those ones I should have memorized, but that's fine. So AC is 41 and AB was 40. Okay, now we have a rhombus. W, X, Y, Z. Their diagonals meet at M. And we're told WM is 3x plus 7. And YM is 5x minus 3. Oh, weird, I wrote this backwards. WX, YZ. Okay, WN, YN is 5x minus 3, and we want to find WY. Okay, well, we know these two are equal because the diagonals bisect each other because it's a parallelogram. Subtract 3x, add 3, we can plug it back into either one of these to get half of the length WY. So I'll just do WM equals 3 times 5 plus 7 is 22. So WY must equal 44 because it is twice. Okay, JKLM is a square. I should probably make a bigger square. For labeling purposes. So J, K, L, M, and the diagonals meet at R. And MJR is 8x plus 5. And KRL is 7y plus 6, and we want to find x and y. This is actually one of the easiest ones we've done because remember, a square at any rate is a rhombus. So this is going to be 45. These are all going to be 90. So this one is 90 for free. These are always going to be 45 if it's a square. So 8x plus 5 equals 45. So from this one, we get 7y is 84, and y is 12. And from this one, we get 8x is 40, x is 5. So because it's a rhombus, these four are each 90, 90, 90, 90, 90. Because it's a square, that meaning these are 90 as well, then each half, these are split evenly because it's a square and 45. Okay, so I have a rhombus. And the diagonals meet at D. I can start anywhere I want with F as long as I either clockwise or counterclockwise go in order F, G, H, K. So what I did before wrong is that I went W, X, Z, Y basically. So I can go F, G, H, K starting over here and going backward, or I can start F, G, H, K. I just have to keep going in order. So F, K, D, so this is 7x plus 10, and H, K, D is 4x plus 31, and then F, D, G is 17y minus 12. So because it's a rhombus, 17y minus 12 is 90. So 17y is 102. So y is, I think, 6. And then these two are the same. So 4x plus 31 equals 7x plus 10, because with a rhombus what you get is 4 similar triangles. You have sides the same, and then sides the same, because these are all bisected. So we have that these are equal, so subtracting 4x and subtracting 10. And this time we were only asked to find the values of x and y, so we're done. Okay, so this is a question of how specific can you be. We want to come up with the best name. So for A, am a quadrilateral with both pairs of opposite sides parallel, so it's a parallelogram, and one pair of adjacent sides congruent. Since opposite sides are congruent always, if you have one pair of adjacent sides congruent, then all of them are. So the answer is a rhombus. You don't know anything about the angles, so you can't say it's a square, but you know all the sides are the same and that it's a parallelogram. I'm a quadrilateral, with both pairs of opposite sides parallel, and diagonals are congruent. So the diagonals are the same. So both pairs of opposite sides parallel means you're a parallelogram. If your diagonals are the same, then you're a rectangle. Because once you tilt it, then the direction you tilt it has a longer diagonal. If you imagine, like, here's a rectangle, diagonals are the same, but once you tilt it like this, that one's shorter and that one's longer. I am a quadrilateral with all four sides congruent. So we know that the opposite sides are congruent, which makes it a parallelogram, and in fact all four of them are. So again, you're a rhombus. Diagonals are congruent, so they're the same, and they're perpendicular to each other. So if it's a rectangle, just ordinarily, you don't have them the same. These are smaller and these are bigger, because remember, how big your angle opens determines your side length. So if you have some sides longer than the other, then the angles opening to those will be bigger than the others. So if they're all the same and they're perpendicular, that means that you're actually a square. I'm a quadrilateral with diagonals that are perpendicular, so that makes you a rhombus. They bisect each other, makes you a parallelogram, so this is rhombus. Both pairs of opposite sides are congruent. That's part of the kind of definition we came up with for parallelogram, but there's no other information here, so parallelogram is the best you can do. Adjacent sides are perpendicular, so you're at least a rectangle now. And both diagonals bisect the opposite angles. So if you're a rectangle, just a plain old, that's horrible. Plain old rectangle, then when I draw this diagonal, heavens, because this side is bigger than this angle must be bigger than this one, which means it's bigger than this one, right? So the only way for these to be the same, which it says they are, it says it's bisecting them, so these are the same, these are the same. For these to be the same, these two definitely are the same. These two definitely are the same because they're alternate interior angles. So if these are the same, then all four are, and that means these sides have to be the same as well, because that makes the angles opposite them the same. So this is the square. Both pairs of opposite angles are congruent. So that's, again, just one of the properties of parallelogram, but nothing better, nothing more specific. All pairs of consecutive angles congruent and supplementary. So this one's the same as this one, the same as this one, the same as this one, and they all add up to 180. So rectangle. We haven't even gotten to trapezoids yet, but trapezoid, they wouldn't always be congruent, but you could have some of them be. And diagonals that bisect each other and form isosceles triangles. So on either side of these, so this diagonals that bisect each other gives you parallelogram. But if you end up with a bunch of isosceles triangles, meaning this is the same as this, then it's a rectangle. Okay, so let me see. I think the next slide may go to trapezoids. Yeah, so I'm going to go ahead and stop here and work on trapezoids sometime in the next few days.